In this video, I want to talk a little bit about something that I'm sure you've heard before, showing your work. When you start to move through from high school mathematics into college mathematics, the purpose of your algebraic work is often to unravel a procedure or work through a computation that is just too difficult to do in your head. You have multiple steps. You might have numbers or parameters that are more complicated than just working with integers. You could be working with fractions or decimals. All those things are possible. And the purpose of showing your work is to actually make your life easier. When you're dealing with introductory algebraic concepts, say I have something like x plus 1 is equal to 3. This is an equation that if your task is to find the value of x, you might be able to do that just by looking at, just by instinctively trying out different values in this space and seeing which ones make this relationship true. Right? You might say 2 plus 1 is equal to 3, x is equal to 2, I'm done. And when the problems are that simple, that's a perfectly reasonable approach. But as soon as the situation gets more complicated, as soon as the operations start building on one another, then doing things in your head actually becomes more difficult. There's more effort that you need to exert than if you commit to writing out your steps and working out things on paper or on the board. It takes the effort out of your mind and allows it to be a process that you can conduct it in kind of a relaxed pace at an easy pace. So in this situation, you might say, well, I don't really need to work through this. I know what the answer is going to be, but it's still helpful to show the work. So when you're asking yourself, what should I write down? What we typically write down, mathematicians and scientists at the college level, we write down intermediate steps of our calculations. We don't usually write down what those steps are. So sometimes we see people will try something like this. If I'm supposed to show my work when solving an equation this simple, I might subtract one from both sides. Right? So I've actually put in some symbols to stand for the step that I'm going to perform. And then by subtracting one from both sides, I can get to this step, x is equal to 2. There's an x left over, and 3 minus 1 is equal to 2. Okay, so that's one version of showing work, and that might have been a standard that you were held to in high school classes. But for us, our steps are to measure progress. They're just to keep track of where we are in a computation. And we would probably leave out those arithmetic clues or those arithmetic indicators. I'm not going to write out in words that what I did to get from this step to this step was subtract one from both sides. So there's less that we actually end up writing down, but writing things down and keeping track of where you are in a computation becomes more and more important. Right? So let me show you what I mean. That's a more complicated equation. I think that many people would be hard-pressed, have a really difficult time trying to figure out the value of x just by trying things out. This equation involves fractions, it involves an exponent, so there's a lot of stuff going on there. But if we show our work, if we work through this algebraically, we have the freedom to look at it just one step at a time. And that can really make things easier and actually less stressful. So even though I don't know what the answer is here, I can think about the process of getting to the answer in a much more measured pace than I would if I was trying to do everything in my head. when you show your work, it's really important to give yourself enough space so that everything that you're writing down is clear and you don't lose anything due to clerical errors. Okay? We're working on the board here, so I have lots of space to work with. When you're working in your own notebook or on scratch paper, give yourself enough space to write everything out as clearly as you need to. Okay? I can't tell you how many errors we see or how many mistakes we see because people are trying to write too small or trying to write too compactly or too quickly, trying to skip as many steps as possible. The work really does become easier if you take it one step at a time and record your progress. So let's say that we want to solve this equation for x, and let's go ahead and try to find all the values of x, because I think we're going to get multiple solutions here. Okay, so if I want to solve this equation for x, the first thing that I want to do is to get rid of the square. That's the furthest operation I see away from x. So I can apply a square root operation to both sides, and that is going to introduce a branch because x plus 3/4, that could be positive or it could be negative. So when we square root, we want to think about both of those possibilities and take those both into account. So my first step is going to be to square root both sides of the equation. And what I'm going to write down is the equation after I've applied that square root. Okay? So I'm not acting on the step of the equation right now. I'm thinking about what I want to do to the equation and then writing the result as the next step that I write down. Okay, so I'm applying a square root to both sides. The purpose of that square root is to get rid of the square on the left here. So that'll leave us with x plus 3/4. Now on the right hand side, we have the square root of the entire side of the equation. So this is the square root of 16/9. And I've kind of cooked this problem so that we can do these calculations by hand without needing to worry about anything too messy coming up. So we have a square root, and it's applied to this fraction, 16/9. Square roots or powers, exponents, distribute over multiplication and division. So we can take the square root of the numerator and the square root of the denominator separately. We can do those and work out the details there. So if we do that, and in addition, take into account this branch, we could have a positive or a negative of the square root as an option for x plus 3/4. Then now we're ready to move on to the next step. So the next step I would perform would be to simplify. I would want to get rid of the square root operation and write this in simpler form or reduced form. So we have x plus 3/4. We have the positive or the negative branch, so the positive or negative square root. The square root of 16 is 4, because 4 times 4 is 16. And the square root of 9 is 3, because 3 times 3 is 9. So now we have x plus 3/4 is equal to the positive or the negative of 4/3. Okay? My next step is to remove the 4/3. I want to get x by itself on one side of the equation, so I can do that by subtracting 3/4 or from both sides. All right? So I subtract 3/4 from both sides, and then what does the equation look like after we perform that step? I'll write it first. I'll say minus 3/4 plus or minus both branches 4/3. Okay? If you're happy with these fractions with two denominators, this might be an acceptable place to leave the answer. You have both pieces there. If you've got a grader or an instructor that insists on you simplifying the answers as much as possible, then we're going to need to investigate both branches of this square root, both the positive and the negative branch. So let's go ahead and try to do that and see what we get. So this expression has two parts. We have x, the first x is equal to negative 3/4 plus 4/3. And the second branch is x is equal to negative 3/4 minus 4/3. Those are our two pieces. If we want to simplify that, we need to find a common denominator for our fractions there. So we can do that by multiplying by the missing factors. So this first piece, negative 3/4, we want to introduce a 3 in the denominator. So multiply top and bottom by 3. And the second piece, that's 4/3, we're going to need to introduce a 4 in the denominator. So we'll multiply top and bottom by 4. And let's move these arrows out of the way here. So creating a common denominator there gives us minus 9. 4 times 3 is 12. Plus 16. 4 times 4 is 16. 3 times 4 is 12. So now we've got our common denominator. So the first value of x that we find is 16/12 minus 9/12. And I think that's going to give us 7/12. Okay, so there's one solution to this equation that we started with. The next solution is given by this, 3/4 minus 4/3. We can find a common denominator in the same way. The only thing that's different is the sign of this second piece. So let's go ahead and look at what that looks like. Minus 4 times 3, 3 times 3, minus 4 times 4, over 4 times 3, which looks like minus 9/12 minus 16/12. If we add these two fractions together, now that they have a common denominator, we have a negative 9/12 and a negative 16/12. 9 and 16 gives us negative 25/12. And those are the two solutions that we get. Now they're not pretty. I mean, these are kind of messy fraction solutions. But what's really important here is to think about the algebra methodically. It's step by step. If you're showing your work, you only need to think about doing one thing at a time. You don't need to worry about how long the computation is going to be. You just kind of trudge through it step by step.